Hi everyone, my name is Lishalini Murugan, matrix number DE210059. I'm the contributor for question 1 in this project. So for question 1A1, we have to draw a tree diagram from the equation given. So this is the tree diagram that I get manually and this is the one that I typed. I didn't do the simulation for this one since we can't do tree diagram in MATLAB. And for A2, we have to find dW over dr. So from the manual calculation, I got 2x cos theta plus 4y qr sin theta. And from the MATLAB simulation, I got the same answer where I got 2x, 2y, 2z cos theta and also 2qr sin theta. For question B, we have to determine dz over dy from the equation given. So here we have to move all the terms to one side and let it be a new unknown where I let the equation be h and I get this answer from my manual calculation and I got the same answer from my MATLAB simulation as well. And for C1, we have to determine the area of the region R enclosed by a curve and also a line. So this is the graph that I get when I did it manually, where for the curve, the intersection at x-axis is at -1.2 and also 3.2, and the intersection of line and also the curve is at x equals to -1 and x equals to 2. So the area that I got from the double integration is 9 over 2 units squared. So from the simulation in MATLAB, first I obtain the graph and I shade the region where I want to find the area, and finally I find the area of the region and I got the same answer as my manual calculation, which is 9 over 2. And finally for C2, we have to determine the surface area of the portion of the hemisphere with a radius of 2 that lies between z equals to 0 and also z equals to 1 in the first octant. So from doing the double integral, I get the surface area equals to pi over 2, and the same answer I get from the MATLAB simulation. By using the codings, I get the same answer, which is pi over 2. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Nurul Farah Ain binti Nurhan and my matrix number is DE210088. So for question 2, so this is the manual calculation for question 2 part A. Okay, so from here, I have already inserted the equation into the Maple software. So in order to write your equation in Maple software, the first thing you need to do is to write the command restart, and also since I've also plotted 3D graph, I need to include the width plots for its command. Okay, then I also use this command and we will get this 3D graph. Okay, you see here, this one is quite different from this one. Okay, so this one you need to properly see that this is the x-axis and this is the z-axis. So from here, it is inclined and also parallel to the y-axis. Same goes to here. This is the y-axis. So it proven that the both of the equation is the same cylinder. Okay. Now for the integration. So from the integration, I also do part by parts for this triple integration. So if we straightly insert the equation, we will get 512 over 3, okay, which is the same answer with my manual calculation. However, in order to show step by steps, I'll do the integration by the first part and move to the second part and the third part. Okay, so we will get the exact answer here. Okay, so after we showed the step-by-step integration, okay, then we can prove that this answer is correct. Okay, now I would like to explain that this value of A is taken from my matrix number, the last number. Okay, so now moving to question B. Okay, so for the question B, it is to find the volume of a curved wedge. Okay, so from here, in the Maple software, it cannot shown the lane that have been cut, but from GeoGebra we can see this is the shape. Okay, so we only take this volume to be calculated, right? So from here, okay, I also do the same process in the Q2A. Firstly, I will insert the overall triple integral and I will get 18 to make sure that my answer is correct. Okay, so both software program and also the manual calculation showed that I have the same answer. Now I also do step-by-step integration from the first part to the second part and the last part. Okay, this limit has been given in the questions above. Okay, so we only inserted all the limits and we will get the answer. Same as the manual calculation. Okay, so this is my simulation. So for the last question, Q2C. So the Q2C here, it is for spherical coordinates. So from this, I would like to do this part of simulation by assumption. So I will replace sine theta into m and cos theta squared into n. Okay, with this, it will make the process of integration way easier. So after I do the simple integration here, I will compare, and this 1 to 8 and m squared 2 over 5 is equal with the value of 36.20. Okay, so this is the same value. Okay, so after this pi over 2 has been inserted into the limit, I will also get 181 pi over 10. Okay, so this one is the same value. Okay, so after that, with this, I substitute the initial n and m value into 3. Okay, so now that we have it, we're going to have this one. Okay, so this answer is obtained after we inserted the value of the limit into the final integration result. Okay, so this answer is exactly the same as 39 pi over 10. Okay, with this, it also proven that my manual calculation is correct according to the simulation provided. Thank you.
Assalamualaikum. My name is Muhammad Farhan bin Muhammad Yusof. I am from Section 2 and Group 6. My mention number is CE210182. For this assignment, multivariable calculus, I will be presenting the question 3, and now I will do the question 3A2. So first, we need to declare the question. From the question given, it shows the Fy, F equals to Yi plus S plus 2Yj. So I declare here in the form of bracket, Y comma x comma 2y, and then here it shows the matrix for the f that I've been declared. So for the declaration, we need to put the insert a mapper prompt. This is the mapper prompt, and it can declare any function that you do. So for example, next I declare u as y, enter. So here is the result of your function that you have been declared, and v equals to x plus 2y, enter. So here also the answer of the declaration. Now I want to differentiate du. So I declare new function and just choose from here, calculus. You can choose a lot of things here, as a tangent expression and also common symbol. And now I choose the differentiate of y dy and u. Enter. We will get c it is equal to 1. And now I differentiate, I declare new one, which is differentiate of d, derivative symbol, and I change to dx, and I want to differentiate the v. Now enter, it will shows d is equal to 1. So for this equation, it shows that f is the conservation on the domain because of c and d is equal to 1. Now I'm presenting the solution from the software Mapper 2022, and that I will use for the solution. So I will explain the question 3b. For this solution, I divide it into 3, which is C1, C2, and C3 because of the triangle. So first we need to declare what is the function to declare, we need to type here, insert a mapper prompt. Mapper prompt is very important to declare any function. So this is this blue color, the blue color is the result or the answer for the function that have been declared. So next, for example, x is equal to t, the answer will be x equal to t, y equal to 0, and the answer will be y equal to 0. Next, a, I differentiate the x, b also I differentiate the y. So the answer will be differentiate x, which is t, will be get a equal to 1, and b will be get 0 because y is 0. So continue, I declare c as y as power of 2 times a. A just now is 1, but y is 0. So eventually the answer will be c equal to 0. Next, d is equal to x times b, and b just now is 0. So the answer will be d equal to 0. So for the c1, I integrate with the limit of 0 to 1, c plus d, and the answer of the integration will be 0 to. For the line segment 2, which is C2, from 1, 0 to 1, 2, I declare x, y just like before, but the difference value here. For the line segment C3, from 1, 2 to 0, 0, I declare x, y, and the declaration for the differentiation. So here it will differentiate based on the what we declared. C total. So I declare all the answer here, C1, C2, and C3. The answer here, and I declare C is equal to C1 plus C2 plus C3, and the answer will be 1 over 2. Q3C. So I declare M is equal to Y power of 3. And the differential of M will be 3Y over 3Y power of 2. And I declare N as S power of 3 plus 3Y power of 2 times X. And C, I put the differential of N minus 2 differential of M. And the answer will be 3x power of 2. Double integral with the limit of 0, 1, x power of 3 and x, c dy dx. The answer that we will get will be 1 over 4. Last but not least, the question D for the question 3. Find the work done by the force moving an object from point -2, 4 to point 1, 1 along the curve y x power of 2. So I declare x equal to t and y equal to t power of 2. Here is A. I declare A as x power of 3 times y. So it will done work, and the answer will be get t power of 5. So next B will be x minus y. I declare here, and just like before, it will continue same just like above. And F is the A B. R is t power of t power of 2. Here it will be declared here. The blue is the answer, and I declare C as the differential of R, which is here. Differential of t will be get 1, and differential of t power of 2 will be get 2t. And the W will be the integral of f times c with a limit of -2 to 1, and the answer automatically will be perform 3. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Rajesh Hamil Hakimi bin Rajadullah. My metric number is DE210064. Okay, next for question 4A. Okay, calculate the surface integral of double integral of sigma y square plus 2yz ds, where the sigma is the first octant of the plane 2x plus y plus 2z equal to 6. Okay, for the 3D graph for this equation, we do this on GeoGebra 3D calculator. Okay, we type it again, 2x plus y plus 2z equal to 6. Okay, this is the graph, the 3D graph for the equation. Okay, next we must find z. So we divide this equation by 2. So we get z equal to x plus y over 2 minus 3. Okay, next to find the s, we do this equation where 1 from this equation and negative 1 over 2 from y from this equation. Okay, next the answer is ds equal to 3 over 2 dA. Okay, next, for the double integral of the equation, we do this calculation, and we get the answer is 1 to 1.5.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Muhammad Yassin, and my metric number is DE210097. So we go to the next question for 4B. So we use the GeoGebra 3D calculator to find the graph for this problem. So we put the value of x power of 2 plus y power of 2 plus z power of 2 and equal 4. So this is the graph for this problem. So next we go to the question number 1. Find the division of f. So for this question, we must do the integration. Do the differentiate of 7x 0 and minus z, and then we will get the value of 7 plus 0 minus 1, and the answer is 6. Next, we go to the question number 2. Evaluate the following surface integral by using Gauss theorem. For this problem, we must find the value of z using the equation that given on the question B, and then we use the triple integral to find the value, and then the answer we will get 64 pi.
Okay, next for question 4C. Okay, the question is verify the line integral and surface integral by relating them to the Stokes theorem, where C is the circle of x square plus y square equal to 1 on xy plane with a counterclockwise orientation looking down the positive z axis. Okay, the equation is the vector of f equal to z square I plus 2xj minus y the power of 3k. Okay, for the equation, we can get the 3D graph of this equation from GeoGebra 3D calculator. Okay, we insert the equation x square plus y square equal to 1. Okay, as we can see, the 3D graph look like this. Okay, next, to find the equation, to find the answer, we do this from left hand side by using Stokes theorem. Okay, we using the counter integral of z square I plus 2x square j minus y of the power of 3k and dxi plus dyj plus dzk. Okay, we do the calculation and then we get the answer is 2 pi.
Now we must verify the answer for the left hand side. So we use the right hand side by using gradient product f. The first one will get the value of minus 3y power of 2i plus 2z j plus 2k, and then we must find the value of z. Then we find the value of dz per dx and value of dz per dy. After that, we must use the double integral gradient dot f and ds. After that, we will get the answer 2 pi. So for the answer, it will same as left hand side, so the value of 2 pi is verified.